So I wanted to take you through the concept of solving a system using Desmos, just so that we can kind of streamline that process moving forward. And so what I'll do is I'll just kind of go back to an example that we covered in class. And, we don't really need the context of it. We just want to talk about the system of equations to begin with. So what we're going to do is we're going to apply a linear algebra concept. And it's solving a system using reduced row echelon techniques, all right? So row reduction techniques. So the first thing that we would do is write this as a product, all right? So product of a 2 by 2 square matrix, negative radical 3 over 2, 1/2, 1/2, radical 3 over 2, all right, multiplied by the magnitude of T1, magnitude of T2. So we're treating magnitude of T1, T2 as a vector in and of itself, right, a vector quantity. And so that should result in a vector 0, -50. All right. So that first vector, negative radical 3 over 2, comma 1/2, or not comma 1/2, but negative radical 3 over 2, 1/2, down the column. Sorry, across the row would be multiplied by this column vector, which would give you this first expression. Oh, changing the color is not found through that menu, right? And so multiplying 1/2 radical 3 over 2 multiplied by that same column vector would give you this result, all right? So now it's just a matter of kind of getting the job done here. All right, so what we do is we kind of strip this down into a 2 by 3 matrix. So negative radical 3 over 2, 1/2, 0, 1/2, radical 3 over 2, -50. All right. Now this technique is only going to work for us because we had our equations in the appropriate standard form for linear systems. All right, so we're looking at it's in the form of ax plus by equals c. All right, now the a's and the x's are reversed, but that doesn't make a difference. Multiplication is commutative. All right, so now what I want to do is I want to have Desmos do the work for me. So what I do is I go into Math Tools and I go into Matrix Calculator. All right, so I'm going to tap new matrix. All right, I'm going to influence the number of columns to become 3, and then I'm just going to type in what I have. So negative radical 3, with the right arrow there to get out of the radical, divided by 2. right arrow, 1/2. That's equal to 0. So right arrow, keep right arrowing until you get to where you want to go. 1/2, right arrow, radical 3, right arrow, divided by 2. And then one more series of right arrows, and we put in the -50. And so that's our matrix A. You lock that in, and then you could see at the bottom, we'll call that, like I said, we'll call that matrix A. I'll just make a little note here. All right. So I want to apply the reduced row echelon technique to that. So rref A, close them up if you want to, but not necessary. And what we get is our set of solutions, which is great. It's just a question of understanding how this translates to, rref, a set of solutions. All right, so we have 1, 0, 0, 1. We have -25. And then I'll just round the next one to -43.3. right? Approximate value. If you think back to where we all started, or where this all started, it was stripped down from the product of two matrices. So let's unstrip it down from a product of two matrices. So this is really the same as saying 1, 0, 0, 1 multiplied by T1, the column vector T1, T2, and that would be equal to, oh, that took off on me, negative 25, negative 43.3. When we apply matrix multiplication, we're going to apply, I keep doing that, I don't know why. We apply the first row against the first column, and since there's only one column, it's 1 times T1. I'll write the intermediate step, so 1 times T1 plus 0 times T2, and that's going to equal the first entry there. And the rationale behind that, I'm just giving you the short and sweet version because I know not everybody in Calc 3, which is what this video is aimed for, it has taken linear algebra, has much experience with it. But this is row 1, and this is column 1. So our final result should be in row 1, column 1, right? So in the resulting matrix, we should be looking at, or looking for, our answer in row 1, column 1, right? And that's what happened there. There's only one column, so I'm not worried about the number of columns, but it is in the first row of quote-unquote column 1, right? So that should give me a negative 25. And then we would do the same thing. See, I'm learning. 0, 1 multiplied by T1, T2. And so that's row 2, still against column 1. So this is row 1, column 1. This one is row 2, column 1. So we're getting the result from where the operation tells us to expect to get the result. All right. So that tells me that 0 times T1 plus 1 times T2 would be equal to negative 43.3. All right. Now there's a shorthand way of addressing this, but I'll get to that in a second. This is more theory, like a combination of theory and practical, a practical approach. So T1 is going to be equal to negative 25. T2 is equal to negative 43.3. All right. So what we're gaining from this entire procedure is that we didn't really have to write down this entire procedure, because if you really consider all of the ingredients here, what we did, going back to the very first step, is we identified the coefficients. Well, first we had to make sure it was in the appropriate standard form. All right, so that's something that we had to guarantee was in play. We took note of the coefficients. We made a 2 by 3, I almost said square matrix, 2 by 3 matrix. And then we applied the reduced row echelon form, the elementary row operations technique, to get us all the way down to that. And then our solution just ended up being, and I'll just keep circling in red, our solution just ended up being those two coefficients. And that correspond to T1, T2 in the order in which they appeared in the system of equations. T1 came before T2, therefore negative 25 comes, because negative 25 comes before negative 43.3, that corresponds, the negative 25 corresponds to the T1, negative 43.3 corresponds to the T2. All right, so it's a very, very streamlined approach to solving a system of equations. All right, so you could find a much simpler example to work on and you know, just something all the way back in Algebra 1, college algebra, trig, whatever class you took, and you'll see that it's going to work every time if there is a solution. All right. And even if there isn't a solution, there's an indication in the approach that'll say, hey, I don't think there's a solution to this. You'll see. All right, so I'm going to stop this video, and hopefully you found it to be helpful, but because we're going to be using this content moving forward, so you know, you could do it by hand. You saw what it looks like by hand, but you could also benefit from learning this shortcut technique.